Okay, so welcome back to the second part of your Rhinocam workshop, Rhino CNC Router workshop, Rhinocam Setup. You should already have gone through this first step here of setting up Rhinocam, getting the stock setup, the zero setup, and the tool library loaded and the post processor loaded. If you've done all that, ready to go ahead and set up a toolpath, we're going to show you in this one, how to do the spiral contour. This one is really pretty easy. In order to make a toolpath, so make sure you have Rhinocam machining browser open, make sure mail. In order to make a new toolpath, I'm going to go to machining operation under 3-axis, and I'll choose spiral machining. There you go. And so in this dialog, we're going to set up all the settings we need to. First tab is the control geometry, which means the boundary that Rhinocam works within. So we want to make sure we have a kind of rectangle that defines the inside workspace of our geometry here. I'm going to go ahead and Rhino and real quick make a rectangle. Do the rectangle and trace that inside out stock. Then in here in control geometry, we're going to go to that first option down below, hit select curve edge, select that curve, and then press enter. You can see a little show up in this list here, and you should find that it kind of shows up as an orange outline in your viewport. So once again, that's just going to tell Rhinocam we only want you to cut within this. The next thing will be to select a tool. In order to select a tool, if we go to this next list over, again, you should see a bunch of tools already in this list. They're loaded in the first video and the setup video. If you don't, go back to that video. Basically, each one of these tools is numbered. That's how we identify which one to put on the router when we're cutting. The next bit is the kind of geometry of that router bit. Double click on it, get this little diagram. I'll show you like the flat mill one just means it's a flat bottom. Generally that's better for a more orthogonal geometry. And then the ball mill or the ball nose ones have like a little spherical bottom. It's generally better for curvilinear or curvy geometries. Go ahead and click OK. Next bit of information is the diameter of the bit. We have everything from a 3/4 inch all the way down to an 1/8 inch. And generally speaking, you're using a larger bit to do the roughing pass. Roughing just means that if you were cutting something harder like wood or something like that, you would want to do a roughing pass to kind of remove a lot of the material more carefully. And then so you'd use a larger bit for that to kind of work quickly. And then you would come back in with a smaller diameter bit, type of bit like a ball nose, and do the finishing cuts to get more precise geometry. Then the other thing to look out for when you're selecting a bit is the length of it. And real quick, if you select any one of these bits and you go to comments, hover over that little box there, it should tell you what materials are kind of okay to cut with that bit. So some of them are foam only. Obviously, that means you want to use them on wood or something. But if it's a wood bit or a plastic bit, it's fine to use. The foam's not going to hurt it. So the last thing to look for is the length of the bit. If you double click on any of these bits, again, to get to this little dialog, you'll see down here where it says tool length. That's the length, this 3-inch bit. And so, for example, you want to choose a bit that's long enough. So if I was cutting a 4-inch block of foam, I wouldn't want to choose this bit because it could mean that the tool would kind of run into the material. We want to choose a bit that's long enough to reach the kind of depths of the cut without running into the stock, without running into the material with the machine. So we're going to choose number 16, just so that everyone kind of has the same tool. It'll make it a lot faster for cutting, get everyone through cutting their molds. So select number 16 there, and then go to the next tab over where it says Feeds and Speeds. And under Feeds and Speeds at the bottom here, we're going to select Load from Tool. What this is like it's the speed that the router moves and the speed that the bit will spin. Again, these are all values specific to the bit that you're using. So every time you change a bit or select a bit, you just want to go over here and hit Load Tool. Should be good for that setting. Next, we'll go to this Clearance Plane tab. So this defines basically when the machine is going to go cut a toolpath. When it's done cutting a certain toolpath, it'll lift up, move somewhere else to start cutting again. And what we want is for it to not kind of accidentally cut through any of our stock material while it's going from one toolpath to another. And this clearance plane defines like how high it moves up between cuts. So we can go ahead and leave this on default for now. It's just going to take stock dimension and move a little bit above that between toolpaths, so that works fine now. Next, we'll go to cut parameters, and under global parameters here, we're going to look at this stock value. And basically, if you look at the diagram on the right, this number represents like an offset away from the finished surface. And if you were doing like a roughing pass, like I mentioned earlier, you would want to leave, like an 1/8 of an inch or a 1/16 of an inch here. You're not cutting all the way to the finished surface and possibly messing up the surface on the roughing pass. And then on the finishing pass, you go ahead and set. So because right now we're cutting, just one toolpath, we're going to set that to 0, so that's to the finished surface right away. And then down below, the other option we want to look at is the step over control. Kind of see in this diagram, basically that's how far apart each kind of subsequent toolpath is. And we always want to have that set depending on the diameter of the bit, obviously. We never want this number to be more than 50%. Because of the way the kind of router bit spins, it's only actually cutting with like half the kind of side of the bit. We never want that number to be more than 50%. Now we're going to go ahead and set it to 40%, just so we can work a little quicker, save some time. And the final thing we want to set in here is under the spiral parameters. We can leave the minimum radius value alone. We just want to check this option, specify center point. And in order to specify the center point, it'll depend on your geometry what you want. But you can kind of see from this diagram, it's going to spiral out in a series of kind of concentric circles, and we want the center to be set in some way to correlate to our geometry here. So in order to set the center point, I'm going to go and click the little cursor, and then we can snap to some point in Rhino. My geometry, I kind of want it to cut along the geometry of my surface. I'm going to set the center point over here in the middle, so it should more or less kind of follow that shape, and we can move it in and out and test it later. And then the next tab over, just double check, sometimes this happens, I don't know why, but that number didn't change back to 25. Make sure that step over tool diameter is set to 40%. And then we'll go to Z containment. And it's always good, so we're going to hit this option, specify lowest Z. What that means is it's the lowest kind of point that the toolpath will go in the Z dimension. And we always want to specify lowest Z, just so we can ensure that, maybe if our geometry isn't quite perfect, if there are holes, Rhinocam could potentially, like go over one of those holes and cut down into the geometry. It would ruin our part, and it could potentially cut into the router bed. Which would mean. So what we want is to specify like the lowest point we need this to make sure that if anything does go wrong, it's not too bad. So because we model our geometry with a 1/2 inch base, go ahead and set that number to 0.5. There. Oops. So that plane will move up at the lower point. And then the last tab is entry and exit, which we don't have to mess with. We can leave that as default. And when you're done, go ahead and click generate. And down at the bottom here, these are our kind of visibility toggles. So the third from the left is our toolpath visibility. Go ahead and turn that on. You should see in your viewport these kind of blue lines appear, which show where the toolpath is going to go, where the router is going to cut. Once we've done all those things, then we can go. What we want to do next is actually simulate our cutting for a couple of reasons. In order to simulate it, I'm going to select the setup again, right click, hit simulate, and it'll show us this little animation of what the cutting process will be like, and it should give us some kind of idea what that final surface will be like as well. And the other thing that this is good for, and we always want to do this every time we set up a toolpath or change a bit, is checking whether or not we have any collisions. So as I mentioned earlier, if you choose a bit that's too short and the machine's going to run into the tool, when you go to simulate it, it'll give you this kind of red geometry, showing you anywhere that the tool is actually running into your stock as it's cutting. Because that bit isn't long enough to kind of reach the cut surface, the machine is running into the stock. So we always want to simulate to make sure we're not having any collisions like that. And then once we are set up here, the last thing we want to do is, if you look on the assignment again, you want to make sure that your file is not over 5 minutes runtime. So in order to check the runtime, again, we'll select setup, right click, and go to information. That'll open this little menu and it'll show us kind of an estimate of how long it takes to cut. And so as long as that number is less than 5 minutes, we're good to go. Go ahead and click OK. If it's not less than 5 minutes, there's a couple things you can do. One would be to go to cut parameters again and set that number higher. So, the less kind of distance of the toolpath, the faster it'll be to cut. Or if you really can't get it under 5 minutes, I would recommend you go back and select the parallel finish. Do that kind of setup and watch that video to get that number down. Okay, so once we're all set up here, the last thing we want to do is post our file and check it for any errors. So again, I'm going to select setup, right click, and select post. And it'll ask where I want to save the file. I want to rename it to whatever it is. Make sure you put your name in this file name. And I'm going to save it spiral. But for some reason, my post processor isn't working properly. But for you should see a text file like this. And this is actually the G code file. So you'll notice this is the .tap that we set up in the first video. What this kind of file is it's a G code file, which means it's actually just like a kind of sequence of X, Y, and Z values. They're basically telling the router what position to go to. So as it's kind of tracing those toolpaths, it's just kind of moving from point to point, one kind of position to the next. And so if we look here at the X, Y, if we look at the Z value, because we zeroed our block to the bottom of the bed, if we were to find any values that were less than 0 Z or negative Z, that would mean that the router is going to cut into the bed. So we generally search this file. We go to edit, find, just search the whole file for Z minus. We'll bring up any negative Z value. So as long as it says cannot find Z minus, that means you're good to go. The other thing you want to search for is M5. Hit find next again. And that will bring up anywhere where you have a tool change. So if you're doing, like I mentioned, the roughing pass and then a finishing pass, you would want to go ahead and just double check that the bit selection is right and check what the kind of sequence of the cutting is. But because we only have one toolpath, that's the end of our file. And once you verify that that is all correct, close that, and then you want to save the Rhino file. So what you're going to upload to D2L, this Rhino file with the Rhinocam setup that you've done here. You'll just go to File, Save As, and you can save it as a Rhino 6 file. Make sure you name it with the proper naming convention, ARC42, 2020S, CNC, Workshop, and then your name. So we know which file belongs to which person. Save that file and upload it to D2L in the proper folder, and that will, and then your TA will go and check that file, post it for you, and they'll let you know if there are any problems or anything like that. And then we'll have those files ready for you on the next workshop. So that should pretty much wrap up the Rhino modeling and Rhinocam setup stuff for this workshop. Go ahead and make sure you upload that file, and I'm going to go ahead and sign off.